2, go.
So, you know how Mars has polar caps like Earth does? Like the North and South Pole both have. See, because Earth, you know how Earth has polar caps at in the North and South Pole. So does Mars, and also the 4 rovers, Opportunity, Spirit, Perseverance, and the Curiosity rovers, all discovered that there is rocks that can only be formed if there was water in contact.
Wow.
So who knows? Mars could have looked exactly like Earth, but we could have ruined it and then came to Earth. Cause the Earth formed when the Milky Way galaxy collided with the dwarf galaxy, and that made the sun form, and tiny particles started colliding with each other, eventually turning into dwarf planets colliding with each other, then turning into regular planets. And that's how all the inner planets, such as Mercury, Venus, Earth, and Mars, must have formed. And that means, if that is so, that means that if they were all orbiting, that means the Earth must have been molten hot like all the other rocky planets at the time. But the gas giants were formed from the gas that was forming. So if that was so, that means that if the rocky planets were molten hot, that means Earth must have gotten stormed by a meteor shower that went on for at least 1 billion years, and each asteroid and meteor had a crystal in it that had a teeny drop of water. So it made the oceans, eventually making it made the water system, so it made the raining system. And then a Mars-sized planet collided with young Earth, making the moon from the debris, making the moon system. And then there was this big, the tectonic plates were crashing. So this is what happened. One of them went down, making a crack in the earth, making a volcano, but eventually got overflowed with water, making a geyser. And then the mother continent, which was the only island on the entirety of the earth, collapsed and fell to the core. And the way the core formed is when all those asteroids hit the earth, and because some of the liquid got molten hot and formed the liquid core, which came the rock, but still burning hot 10 times the heat of the sun. Because that made a strong magnetic field, protecting it from the only thing the magnetic field protected it from at that given time was the cosmic rays. But when the mother continent collided, when it collapsed, it fell to the core. It was toxic, so it melted some of the core. But when it all cooled down, when it all cooled down, it was like it made the magnetic field stronger. so it actually can protect it from not only the cosmic rays but the harmful solar winds. But it was still molten hot. But then, because the entire planet was covered in water, it was not suitable for life, and it could not support marine life because of its atmosphere. But it was near ready for it to support life. Then the crust somehow the crust under gravity made more land, which formed the other continents. So that's how land formed, like the United States of America, for example. And then the atmosphere changed, and then and I forgot how much. I forgot how. I know it has like nitrogen, a little bit nitrogen, but yeah, it had it the the atmosphere was able to protect the surface of the planet. So because of that, it was able to support life, and that entire process took 5 billion years. And because the other planets aren't able to support life because they don't have water. But Mars, that could have also supported life, and because we could have been on Mars but could not get to another planet, and we had messed Mars up. So, and it could have looked exactly like Earth, but lost its color and turned red, like very red. And because of that, it was not suitable for life, but it used to. So, because human life came from animal life that evolved over time. So, if there was no animals, there would be no humans. But also, if there was only animals, the Earth would. But if there's no humans today, the Earth would start to thrive for millions of years because factories would have no one to process them. So water factories would flood the entire Earth, but the plants would soak it up, and all the pollution would go away, and the entire Earth would thrive. But also, the sun is about halfway near its lifespan, so it'll blow up soon. So
But that's still a long time away.
Because from the sun's birth, it will take double the time to make the Earth in order for the sun to explode in a supernova, destroying the entire.
What's a supernova?
The supernova is a massive explosion that can that if it's 10 times the size of the sun, if the star's mass is 10 times the size of the sun, it can either turn into a neutron star or a black hole. A black hole is bad because it would suck everything around it, including light, into it, and it would have this lensing effect due to its gravity is so strong, and you would have to be moving faster than the speed of light. And the singularity is, you probably think this is no space, but it's 10 million times smaller than this. And because of all the gravity constantly pushing down on the black hole's core, and the singularity point is actually the black hole's core, so you would be crushed into that if you were to fall into a black hole. But it depends on how big the mass of the black hole, depending on the time of your death. See, because when you're approaching it, it's not that fast. But as you approach it, it'll get faster. So you can actually do this like with a bathtub and a drain filled with water. Because the whirlpool and then the drain, because the black part is the black part of the black hole is you just looking at the event horizon of it. And the singularity is what I just said, the core. But if it turns into a neutron star, if it gains any more mass, it'll turn into a black hole. Therefore, it will just suck things into it. But because a neutron star is about the size of when you're looking at it, it's about the size of Mount Everest. It would just be the size of Mount Everest, but it has the mass of 10 million suns inside of it.
Wow.
So it has so much gravity that
It'll suck anything in.
It'll suck anything in. But therefore, if two neutron stars can collide, it will actually turn into a black hole. If two black holes collide, if two black holes collide, it'll collide into a bigger black hole. But both of them will be orbiting each other, like I'm doing with my fingers. So it'll be faster until they both just collide into a bigger black hole, sucking more things. So, but if it has way more or less mass than if there's a smaller black hole colliding with a bigger black hole, you won't believe this, but because it breaks physics, but it will send the black hole flying at faster than the speed of light. And also there's white holes. If a white hole collides with a black hole, the black hole will suck the white hole in.
What's a white hole?
A white hole is the opposite of a black hole.
Meaning
It spews out space-time. See, because a black hole is constantly
sucking in
space-time.
So the white hole pushes out
space-time from the singularity. Therefore, making it so fast that even though the white hole is constantly pushing you in, it's also pushing you out. Therefore, you have to be traveling faster than the speed of light to escape. So therefore, making it impossible to enter the white hole's event horizon. And because that, you would be stuck there for eternity. Also, the universe is not infinite. The universe is infinite, or so we thought. There's actually a huge wall at the edge. And if you go past that wall, you will be into a super void that if you travel exactly 1 billion light years, and a light year is the distance you would have if you traveled a year. If you were traveling the speed of light, and you were traveling the speed of light for 1 year, so you would be dead by the time you reached another universe. And there's already like trillions of galaxies that we already don't know of. And also the end of the world can occur when the Andromeda galaxy collides with the Milky Way, because every single last star will be fully powered. therefore the Earth will no longer. Therefore, we will have to be in the place of Saturn, the sixth planet in the solar system, in order for Earth to survive. In order for it to support life. Therefore, Saturn will be able to support life unless, because we would, because the only way to survive after the Andromeda galaxy collides with the Milky Way is to get the Earth, the sun to lose half of its mass. And if that happens, that means it'll be able to support life because it'll gain twice the mass. So it'll be 2 times the mass. So we have 2 options. Either figure out a way to slice the sun in half, making its mass even smaller, but also we would have to be slicing it in half as the Andromeda galaxy collides, because if it doubles down in size before the 2 galaxies collide, that means the Earth would not be in the habitable range of the heat.
What's habitable?
Habitable means the range of which a star's heat travels.
So if we split the sun in half, is it still going to give us enough heat for the Earth to survive?
The answer is no.
So why would you want to split the sun?
We would have to split the sun in half in order to survive the 2 galaxies colliding, because if we split the sun in half as the 2 black holes, as the 2 supermassive black holes collide, because it actually depends on where the middle of both black holes are. So, and black holes colliding is just like water colliding. Because as soon as water collides with other...
It mixes.
It just mixes. It just collides. So it will just collide into one galaxy. Because the sun will gain twice the mass, we either have to wait until they both collide to split it in half, or switch places with Saturn, or option 3 is just to wait until after they collide and then split the sun in half. Because space travel will be way easier because it's going to be in the future.
Right.
So this is going to be easy. Also, because the thing is, the confusing thing about black holes is they don't follow the laws of physics. Therefore, you would not ever understand them. Even though it's a black hole's core, the singularity is infinite. It may be infinitely dense, the sun's gravity is constantly pushing down on itself. But the reason the sun does not just collide on itself, just crush down, is just because because the core is also constantly pushing out anti-gravity. So it has the same amount of gravity, but it's just anti. And anti means opposite. And if it's anti-gravity, that means if the Earth's core was anti-gravity pushing out and no gravity pushing in, we would all be in the space right now. So Our sun has anti-gravity and regular gravity. And actually, because if a grain of sand were to hit Earth because if a meteor were to survive the Earth's atmosphere, but turn into the size of a grain of sand, it would have as soon as it exits the atmosphere part, it would be the size of a grain of sand.
Wow.
And if it hits the ocean, it'll boil it, making massive tsunamis and storms. And it would be
a lot of depth.
It would be digging to the Earth's core, and if it drills through the Earth's core, the entire planet explodes. But it would be slowing down, and hopefully if it survives, hopefully if the Earth survives, we can survive the major storms we're having and tsunamis. See, because it's gonna be massive flooding, because it's gonna trigger every single last. See, because it's gonna trigger earthquakes, tsunamis, like flooding, major storms. It's also tornadoes. All of them. See, because it may actually trigger every single last natural disaster that ever happened on Earth. Just twice the power. And see, because if that happens, it might be good for the Earth, because it's gonna start, because every time something ends, it's a new beginning.
Right.
Because you know how I said that the sun would have to be 10 times its mass in order for it to either turn into a neutron star or a black hole? Yeah, it would have a new beginning at the end of its death. So that therefore we would be able to survive using gardens that would be underground.
So which one is it that follows physics?
White hole or black hole? Yeah.
So you said black hole doesn't support physics.
Yeah, actually, yeah. Also, white holes don't.
Neither one of them.
Neither one. Because the white hole is just constantly pushing out space-time from the singularity.
Black hole is sucking it in. See, I'm learning a lot listening to you.
Because which one is hotter, Mercury or Venus? You guys are probably gonna say Mercury.
I was gonna say Mercury.
Because it's the closest
to the sun.
But because of Venus's thick atmosphere, it traps the heat. Meaning, therefore, it's the hottest. But one of the cool things about Mercury is it has more craters than any other planet because it has no atmosphere.
So everything bombards. Which wouldn't be a great place for life, because you would be under total bombardment all the time.
See, because
how many planets are there?
8.
And it used to be 9, right?
When I was born, there was 9. But
and what happened?
But Pluto turned into a dwarf planet
How did that happen?
Because it has to be spherical, which it is.
Spherical? What's that?
No, it has to revolve around a star. It does, and it also has to clear its path from asteroids. It doesn't, because it's too small, and Mercury used to be the second biggest. Now it's the smallest.
Mercury? Wow.
And
so why is it diminishing in size? Why is Mercury diminishing in size? Why is it getting smaller?
No, No, Mercury is the smallest because
It's always been the smallest.
No, Pluto used to be the smallest, but because Pluto isn't a planet anymore, see, because Pluto used to be the smallest planet.
Right.
But now it's a dwarf planet, meaning it's not a planet. And now because Mercury is used to be the second smallest, it is now the smallest. And because it's very hot, but it's even hotter on Venus, and there's barely any craters, but due to its very thick atmosphere.
So name the planets as it pertains to heat, the hottest to the coolest.
It would be Venus, Mercury, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
In that order?
Mm-hmm.
So Neptune is the coolest?
Mm-hmm. Because it's the farthest. But Pluto used to be the coldest.
Because it used to be a planet.
Mm-hmm.
I didn't even know that Pluto wasn't a planet anymore.
Mm-hmm. See, because there's 5 dwarf planets. I can't remember their names for some reason. But Pluto is one.
So what's a dwarf planet?
A dwarf planet is a planet, but it's just not. But it's a planet, but it's also not a planet because it's smaller, and it can't see because. Well, I don't know how to explain it, but a dwarf planet is kind of like a planet, but it just is too
It's
small.
Small, right?
Mm-hmm.
That's why they call it a dwarf.
Mm-hmm.
Okay.
And a dwarf galaxy is a galaxy, but it's just too small.
Okay.
And if we exit the universe wall, we would be into what would be called a super void, which is 1 billion light years away from another universe. And our universe could be colliding with another universe. And what can be holding universe? A different dimension. And there could be different dimensions that hold different universes, that hold different galaxies, that hold different stars, that hold different Earths.
Yeah, because theoretically, they were saying if you entered into a parallel universe, that you could find exactly what you have here there.
Mm-hmm.
It's just a theory, but that's what they say.
Mm-hmm. And who knows, one day we might be able to go different dimensions.
Right.
And see, because the thing about planets is they're always spherical. And that is because of gravity. So if the Earth was flat, it would not stay flat for very long before gravity pulls it back up into a sphere.
Well, what would make it flat?
No one knows. If there is no gravity, it might be flat.
Oh,
but
okay.
since there is gravity, it's spherical. Mm-hmm. And see, because if the Earth was a square, even though it would not stay square for long, you can just go to one of the corners and you would be lighter.
Oh, okay.
Since the corner is farther from the core. So
the farther from the core you get, the less gravity you get.
Mm-hmm. And see, because why do you never want to fly a drone above the clouds when there are no clouds on that day? Because you don't know where the atmosphere is. And if you don't know where the atmosphere is, you're probably going to fly out of it. And your drone's going to be stuck in space. And if you fly out the atmosphere, your drone's just going to be sucked right in. But
Boom, gone.
but it would just turn into dust
Right.
unless your battery, which I need to install a parachute thing onto my drone.
So if the battery goes dead, the parachute ejects and the drone falls safely back to the ground.
Especially if it re-enters the atmosphere without me knowing. Because thank God that I only have an altitude max of 322
feet.
And I forgot how. And I forgot the length before you exit the atmosphere.
Yeah, we need that.
I think it's 1,000 something feet. Yeah, I don't know. But also, because if there's a comet heading for Earth, it will have to get past Jupiter. But Jupiter's gravitational force
will pull it in.
And it'll crash into Jupiter.
So it's almost like Jupiter is our bodyguard.
Yes, it actually is. Because Jupiter is a gas giant. Because Halley's Comet crashed into Jupiter.
Oh, did it? I didn't know that.
Yeah. I knew that.
And it just burned up?
When it hit, the explosion was visible from Earth.
Wow, really?
It was like massive.
You saw it?
Huh?
Did you see it?
Yes.
Wow.
Yeah.
You know what I have to get you?
No, it actually occurred in 2018.
You know what I have to get you? What?
A telescope.
Yes, sir. A good one.
See, and a microscope, so I can actually know what that moon rock that almost hit me in my face.
Where did you get that moon rock from?
Oh, at school when it almost hit me in my face.
From where?
It came from the moon.
Yeah, but I'm saying, how did it almost hit you in the face? It came from the moon to your school?
Yes. It came from the moon for some reason. I still don't know if it came from the asteroid belt or if it just came from the wall of asteroids that is protecting that is actually protecting our solar system that collides that almost collided with my mouth. No, not my mouth, my nose.
Wow, I didn't know that. When you told me that, I thought that somebody just brought it to school.
No, it actually came from the moon. I don't know if I was supposed to be terrified or lucky.
Right.
Because one, that thing should almost be like $1,000 or something. And two, I don't know if I was supposed to be terrified that thing almost
killed you.
And I also don't know if a astronaut just decided to kick it.
Yeah.
Yeah, that could have happened, and they didn't know. They thought it was just gonna. Well, wait, but if it's in space, that means. Wait, that means that. That means that.
What am I doing?
Blowing it back. So if an astronaut kicked it, they must have thrown it, because it must have been like 3 times the size of this house, in order for it to actually get past the atmosphere.
Right.
And if so, that's why it's only like this small. No, wait, like this small. Imagine there's this small.
Do you remember that United States dropped a bomb on Japan?
No.
An atomic bomb. Killed a lot of people. The reason I bring that up is when you talk about asteroids and things like that, they come down and they do a lot of damage.
Yeah, especially when they hit the sea. The sea is like the critical part. And most